Hi there. Today we are going to do applications day 1 for exponential functions. So this first problem here is kind of a warm-up because I'm giving you the equation already. Later on, I'm going to show you how we're going to write that equation. Okay, so city library is increasing number of books. So increasing, notice here, okay, my growth factor is greater than 1. That makes sense. 5% per year, okay? And we currently have 40,000 books. So our equation is written like this. My 40,000, my initial value, is the number that goes in front of the parentheses. Then my 5%, I take 5% and I'm changing it to decimal. So I'm going to move it 2 spots to the left, put a 0 there as a placeholder. Since it's increasing, I'm doing 1 plus 0.05. That's how I'm getting my growth factor greater than 1. So think of it, it's growing at like 105%. All right, let's change this x here to t real quick. Okay, so how many books will the library have 8 years from now? Off to the side, I'm just going to write what my variables stand for. T stands for number of years. And then h of t, the number of books, just so we can keep that straight. Okay, so I have my equation, h of t equal to 40,000 times 1.05 to the 8th. Okay, so this is when you have to have your calculator. You're going to type that in with your exponent button. Okay, so you should get 59,098 books. That's a comma there. I'm not rounding up because I don't actually have that extra last book. I can't have like 0.2 of a book, so I just round down. All right, then 20 years, that means t is equal to 20. So I have h. I'm just going to place my 20 in here. That's my function notation. It's just telling me I'm plugging in 20 for t. I'll type that into my calculator. This number's going to be pretty big. What do you get? Good. Okay, so you get 106,131 books. Wow, that's a lot of books. Okay, so that's our basic warm-up with the equation already given. Now let me show you how you would actually write the equation. Okay, so we're depositing $1,500 into an account that pays 5% interest. All right, when I have interest, my money is getting bigger. So my growth rate or my growth factor, those are two ways to say it. It should be greater than 1. So I have my sorry, I jumped the gun here. I have my 5%. I need to move my decimal space over 2 spots by 0.05. Since I'm increasing in value, I do 1 plus this. So my growth rate or factor is 1.05. I'm going to star this here. This is when it's increasing. All right, and my initial value right here, I have 1,500. Okay, so your general form for exponential equations looks like this. Whatever variable you decide to use, a, x, y, z, whatever, I have my initial value goes in front of the parentheses, and my growth rate or factor goes inside the parentheses. So I have a of y is equal to 1,500 times 1.05 to the y. That's always the same format for exponential equations. Okay, now 10 years, I'm plugging in 10 for y. So this is just showing me, okay, I'm plugging in 10, but really I'm focusing on the right side of the equation, 10th. Okay, so this part here is what I'm plugging into my calculator. All right, so what do you get? All right, you should get $2,443.34. Don't forget to label your answer. Okay, then we have one that's decreasing. It's similar, but I'm going to show you how to find your growth rate when it's decreasing. All right, oh dear, we have 25,000 mice. Yikes. All right, and 20%. So since I see a percent, I need to move my decimal. So move it over 2 spaces, 5.2. Since it's decreasing, I need to do 1 minus 0.2, which is 0.8. That's my growth rate. So what I'm saying here is that I'm decreasing by 20%, which is also the same thing as growing at 80%. Okay, it's not greater than 100. So when I raise this to an exponent, it's going to keep getting smaller and smaller. If you don't believe me, you can do 0.8 squared. It's going to be 0.64. That's smaller. If I square that again, it's just going to keep getting a smaller and smaller decimal. Okay, so now we have an equation. I'm going to write m of y. My initial is 25,000. My growth is 0.8 into the y. Okay, so now I'm going to plug in 5 for the y here. So m of 5, the fifth. Okay, plug that all into your calculator. What do you get? Good. Okay, so you get 8,192 mice. Still a lot of mice, but better than the 25,000 for sure. Okay, let's try a couple more. Now we have a table in our problem. So there's a book thief at the library, and they give us all these numbers. So the first thing you want to do is find your growth rate. You're going to find your growth rate from the table this time. So I got to figure out, okay, what am I multiplying by each time to get the next number? If you don't know, you can always do your bottom divided by the top. So 20,000 divided by 40,000 is 0.5. Okay, so if I multiply by 1/2 or 0.5 each time, I'm going to keep decreasing my numbers. Okay, so I have my growth factor here, and my initial amount is 40,000. Okay, so my equation, I have y equals my initial amount, my growth factor, raise that to the exponent. It's always that same format. So now I'll just plug in 7 right here for x. So y equals 40,000, 0.5 to the 7th. Okay, so we'll figure out how many books are left in 7 weeks. You should get 312 books. Man, that book thief is good. He's stealing them really quick. Okay, and last one. The price of ABC gum is greatly increasing. If you don't know, ABC gum has already been chewed. Yeah, it's getting very popular, as you can see. First thing, if you could just change this 51 to an 81. Here, I'll just write. That's a typo, sorry. Okay, so let's find our growth rate or factor. I'm multiplying by 3 each time. Okay, so if you notice, if there's not a percentage written here, I'm not moving decimals and I'm not adding or subtracting 1. This is already my growth rate ready to go. I don't have to change this. So if a problem says, oh, it's tripling, your growth factor is 3. You don't treat it like a percentage. Okay, so your equation, I have y equals, my initial amount is 1. So I have 1 parentheses, my growth rate, which we just found is this. I have 3 to the x. Remember, you can use whatever letters here that you want. Y, x, z, f of x, whatever you want. Okay, so we figured out, okay, how much we have to pay for ABC already been chewed gum in 10 years. Plug in 10 for x. Whoa, that's expensive gum. Okay, we get $59,049. Yeah, that's a lot. Okay, so that's it for today. Make sure if you see anything on your calculator that looks like this, that's scientific notation. That means it's times 10 to the 11th power. I have to move my decimal spot over 11 times. If there's no number there, I just add zeros in those places. Okay, so that's when the number's too big to fit on your calculator. That happens a lot in exponential functions because it just grows so quickly. Okay, so don't be surprised if you see that. All right, good luck on your classwork.